So in this video, we're going to be talking about naming compounds that contain two different types of nonmetals bonded together. And so we want to be able to do that. If you're given a name of one of these compounds, write down its formula. If you're giving its formula, write down its name. And then also given the formula of water or ammonia, be able to write its name, or other way around, given a name, write its formula. So that's what we want to be able to do in this section. So remember, in a previous video, we split the periodic table up into metals, nonmetals, and metalloids. And the nonmetals are shown here, okay? They're in yellow, and hydrogen is one of those guys. And those are the elements that we're going to be focusing on in this section. So a binary molecular compound is a compound that consists of exactly two types of non-metal elements. So some examples here are a hydrogen bonded to a fluorine, a nitrogen bonded to two oxygens, two phosphoruses bonded to five oxygens. The example shown here, I believe this is a phosphorus bonded to 6 fluorine atoms. PF6 would be its formula. So again, these are all examples of two different nonmetals bonded together, two different types. And again, this is what we call binary molecular compounds. Okay, so the real question then is, how do we name these compounds, all right? And naming binary molecular compounds isn't really that hard. Here's the rules, and then we're going to talk about them and do plenty of examples in this video. The first word is the name of the element appearing first in the chemical formula, including a prefix to indicate the number of atoms of that element in a molecule. And the second word is the name of the element appearing second in the chemical formula, with its ending changed to IDE. And it also includes a prefix to indicate the number of atoms in the molecule. So what do we mean by these prefixes? They're given here, and you can kind of pause the video and write these down or take a picture of it so you can refer to it when we do the examples that are coming up. But these prefixes tell us how many of each atom we have. So let's do a quick example. So let's say we had two nitrogens and an oxygen that formed a compound together. Let's use this example because it's similar to what we use for diatomic molecules. For two, okay, if we have two of a certain type of atom or certain type of element, we use the prefix di. Okay, so what would this guy look like? Let me just write him up here so it's out of the way and I can have more room to write. This is going to be dinitrogen. Okay, so where the di represents the number of nitrogen atoms that I have there. And then it's going to be monoxide. Okay, where this prefix here tells me how many oxygen atoms I have. Okay, so again, this is how we're going to name these compounds going forward. And again, we're going to do several examples together. And I'm going to point out a few things that we need to be aware of when we're naming compounds beyond just the few simple rules that I've given here. Okay, so let's do some examples together. So we're going to write the name of this formula on the top, or excuse me, we're going to write the name of this compound on the top, and then we're going to write the formula of the compound that's named on the bottom. Okay, so first off, all right, I'm going to write the first element. It's iodine, right? And then I want to write down how many I have. It's a prefix, right? So for two, we already saw this one, it's di, as we see here. So this is going to be diiodine. And then we have 5 oxygens here. And 5, we're going to use the prefix penta. Okay? So pent oxide, and I change the last part of the name to an IDE, okay, for the second element. Now, I left out the A here, right? I said penta was the prefix for 5, and I just put pent. For things involving oxygen, you usually drop the A in these names. Again, learning the system. So it's going to be pentoxide, not pentaoxide. That's generally how you'll see it. Okay, for everything else, I believe you can keep the A on there. But for oxygens, it's usually you drop that prefix, the A in the prefix, I should say. Okay, so keep that in mind. Again, like I said, I'm going to try to point these things out as we do examples. All right, so it's diiodine pentoxide. Okay, what about this one? Write the formula of nitrogen trifluoride. Okay, so first element is nitrogen. And now how many do we have? Well, here's another weird rule or something to keep in mind. When you only have one of the first element, okay, the word mono is usually implied. It's not written down, okay? So just by writing nitrogen here implies that I only have one nitrogen, okay? So again, that prefix mono usually, or I would say pretty much never, is included in front of the first element if there's only one, okay? So this is going to be implied here. So this is nitrogen, just one of them. And we're going to do more examples of this if that's not clear. Trifluoride. So tri means 3 if you go to your chart, okay? So this is the formula of that compound. Okay, and we're going to do more examples, like I said, highlighting both of these maybe weird, not exceptions, but nuances of naming in the system, and we'll get more practice doing it. Before we do that, though, two compounds are so common, they're always called by their traditional names. That's water, H2O, and ammonium, which is NH3. And we've seen both of these guys before in chapter 2. So if you're given the formula for water and asked to write its name, okay, don't write dihydrogen monoxide, just write water, okay? Same idea for ammonia. Just write it by its common name. It's just kind of tradition, and it's easier that way because they're so common. All right, these are the exceptions. So let's do several examples together. Why don't you pause the video, write down all of the names of these compounds or formulas of these compounds, and then we'll come back together and review and see how you did. And while you do that, I'm going to grab a sip of water. Okay, so let's do this together. So first one is nitrogen monoxide. And remember, it's implied here that there's only one nitrogen, okay, when there's no prefix in front of it. That mono prefix usually isn't included. So this is going to be one nitrogen, one oxygen. Okay? The next one, we have dinitrogen. That means we have 2 nitrogens. Tetroxide, which means we have 4 oxygens. And again, for the ones involving oxygen, that A at the end of the prefix is usually dropped, okay? So just keep that in mind. Okay, over here, dinitrogen monoxide, that's kind of cheating. We already did that one. That's N2O. Carbon dioxide is the next one. Again, remember, when there's nothing in front of the name of the element, no prefix, it's implied that we only have one of that element in the formula. So this is carbon dioxide, okay, CO2. Okay, so here we go over here. So we have nitrogen. And again, because we only have one of those compounds, all right, or one of the atoms, I should say, we don't put mono in front of that. It is implied. Nitrogen dioxide, okay, where di is the 2 oxygens. The next one is going to be dinitrogen. Trioxide. Again, we have 3 oxygens there, 2 nitrogens. This is the name for that compound. Okay, this next one is going to be dinitrogen again. And then oxide. We have 5 oxygens, and remember that A at the end of the prefix there is usually dropped for oxygen. So instead of pentaoxide, it's pentoxide. Okay, just a weird kind of rule there, or exception. I don't know what you call it. Nuance. I think is what I called it before. I think that's the right word. Okay, anyway, last one, sulfur. Trioxide. All right. So this is the names of all these compounds. That's how we name binary molecular compounds. In the next video, we're going to talk about ions formed by one element. So I'll see you there.